May 21st, 10:55, made it through the border totally uneventfully at about 10 o'clock. And we're heading to San Felipe, all 3 vehicles. So far we're on schedule, right around 11 o'clock, about 90 degrees. And so far so good. So basically today we're going to just circumnavigate the island and then land after that.
Yeah, we're going to land in a few places. Y me quedaba ahí en la casa de él ahí con Don Nati y con Loncho.
Loncho, hace poquito estuvo Loncho aquí, se fue, güey. Ya casi no viene para acá.
Está en
7 a.m. Monday, May 22nd. Clear skies. No wind. Plate glass water. Some pelicans fishing, some other seabirds swimming around, some fish jumping. Cruising in a 48 horsepower Yamaha outboard.
The what? Never found the what?
I never find the muscle. I just find got out the other sides. Not before the less separated from but we find some the microprobe analysis we find volume very high. So it's very important to find the muscle, but I don't get the rock. Okay, well we'll try. We have to try.
It's talking about finding the basalt, trying to find a basalt on the island. As we're coming up to the eastern side of the island, there's some pelicans on small rocks. It seems to be a form of a reef, some green vegetation on some gentle sloping hills. We have Keith Sutter, Gene Machovsky, Francisco Paz, Chris Farrar, Brian Houseback, and the boat operator Gilberto. Channels?
No, that's a ring of projection. You see this part?
Right.
There's a ring of bombs here.
Okay.
And
Oh, yeah.
bombs laid.
Okay.
We have all these rings.
Yeah, the channels, the lines coming down, is that erosion? Okay. The ash gives way to day sight after a couple of fault lines.
This stuff is very blocky down.
Rocks.
Rock?
Yeah.
Rocka? Have you seen those? Have you seen in the layers at Puna Buffeo? There are palagonite beds down low. Okay. Do you think they're the same as the palagonite here?
Yes.
This is the beach.
These are palagonitic surges.
I think that
No, they're surges. Yeah, part of that's this algae on there.
Isn't that in bomb?
Prismatic blocks. They were hot when they were.
Yes. That's why they cracked it like that. They made the floor. Cauliflower. Cauliflower.
Yeah.
Yes.
basaltic andesite, okay.
The only fresh part is the blocks.
Yes.
The ashes.
No, we can find some beautiful origins in the
Matrix?
top. Yes. But more in the central part of the glass, they are very fresh. They have crust, yellow crust.
So, are these plagioclase? Maybe this area.
They have some pleasure there. Only physical.
about this stuff here?
Yeah, the exotic. Some exotic.
What, do you go in any basement exotic?
After collecting a sample of a bomb, we are now heading over to an adjoining island. Weather still warm but calm. Stopping on a small cove on the northern side of the beach. Should be the north side of the island of Poma. Two fishermen breaking for the day, and we're looking at a large on the structure. Look.
Yeah, puffed up. Here's another really old one.
Yeah, right there when I found it.
Light and dark of the same trace of them.
Come on.
Yeah, Arturo, we need you to discuss the geology here. Tell us everything we need to know.
I'll do my best.
We were looking at, okay, so there's Puertecitos, and there's San Felipe, and these are the ignimbrites that are about how old?
There's two periods of ignimbrite eruptions. There's one at 6 million years, around 6 million years, and the younger around 3 million years old. That's the age. Probably, I'm not sure if this changing color will tell us if we are getting the boundary of the 3 million year old tuff that capped the mesa. But anyway, what we know from the work by Joan here in Valle Chico, the work by Claudia Lewis here in Sierra San Fermin, and Elizabeth Nash here in this area, and myself along the coast, we know that we have 3 periods of volcanoes. The older tuffs are around 11, 12. We have the first large ignimbrite eruption. Claudia and Joan think that the vent could be in this area. And for the 6 million year old event, the vent facies are within the Arroyo Matomil, which is this.
And what do the vent facies look like?
It's rhyolite domes, large area of rhyolite dome emplacement, and thick sequence of welded rhyolite top. Mostly it's
Is there any suggestions of a caldera? Structural caldera?
No, as far I know, there's no a place where you can put, this is a collapsed caldera. The only collapsed type structure is around Volcan Prieto here, but it can just be related to this volcano. I don't know if this is related to the whole ignimbrite event, 3 million year event.
It's right in the middle of it, though, isn't it?
What we know of this 3 million year old event is that thickness of ignimbrite deposit thickens toward this area. El Huerfanito, Arroyo El Huerfanito are probably the thickest section that we measured. It's about 200 meters, and it includes Mosen 24, 25 cooling units, at least. And then, so they're extremely thin, but densely welded and have a very large distribution.
Uh-huh.
It drafts the whole area.
Uh-huh.
When we get into this boundary here we have basement rocks, mostly granitic and metamorphic rock.
That's firm form fault.
It's a way to transfer part of the relative
Pull apart.
there's some oblique rifting. You have the transfer faults are like this, and then the shape of the peninsula is kind of oblique to the main fault direction. Then you have all these normal faults that produce the main Gulf escarpment in here, which is active. And then you have an accommodation zone here, which is the Puertecito volcanic province. And then after Gary Axon's idea that the Gulf extension of province is segmented, Laguna Salada with a top to the west upper plate movement, and then here you have top to the east upper plate movement, and then probably here you have another reversal because we don't have a major structure in the escarpment here.
This sort of gray-green color is a tuff, or is a tephra that we think erupted from here, and it drapes over the top of this granitic rock here, this tonalite, and it's all the way down. It's down and through here near Alfonsinas. And there's a little bit of it that's even moved by wind down through here. You can find this. I think it's mostly an andesite or dacite, so to say. And that's the one that I've done crystal separates from, and it's mostly plagioclase and clinopyrites. So there's actually at least two tuffs. There may be more than one deposit of the andesite. And we can go back on the road right out here to the main road and actually see these units deposited right out here on top of the alluvial fan. And it's significant that because they're right on top of the alluvial fan, there's nothing else on top of them. They actually form the surface. So they're young, relatively young. There's one other tuff that is of note. We call it the Faro tuff, unfortunately, because you use the name Faro for your other stuff. But this is a very young sequence, and it's not very well exposed, but it's a white tuff, and it's very, very fine-grained. It's powder. And because of that, it's mostly removed by wind erosion. But there's a couple of places where we can find it. One is a place called Hole in the Wall, which is this big drainage right here. This is a large drainage that has an outlet to the ocean right here. And there's a small area or two in here where that tuff is found. And I think that tuff probably overlies the andesite, which makes sense. If it's rhyolite, it probably should. And anyway, we could go look at some of these tephras here in the alluvial fan, and we could also drive over with four-wheel drive to the Hole in the Wall and take a look at that. Because if we're not going to go out today...
¿Cómo ven, señor Roberto? Nada, ¿no? Caso perdido. Esperamos.
Spot is a satellite, it's a French satellite.
Okay.
And this is their image.
Okay.
So it already, because the master data did not have good navigation, we had to basically put this image up on the screen, put the master image up on the screen, and make what you call ground control points. So I know this is the same point as on my master data. The master images are very, very small, compared to like this is from a satellite, whereas master's from an aircraft. It's much lower, better resolution, but you have to put a bunch of images together to really see the big picture.
And the one fellow who has done some age dating on this caldera dated the what he calls the RO volcanics, which are these are andesite lavas mostly, which form this carapace that's truncated by this caldera ring fracture. And these are approximately 1 million years, 1.09 million years. In the center, there's a resurgent dome, which is unusually high resurgent dome. A resurgent dome is a central feature in a caldera that is pushed up after the caldera erupts and very typically pushes up the material that is down in the caldera basin. Usually that is the caldera forms usually by the ejection of a large volume of usually silicic magma and produces ash flow tuffs. And because there's so much material erupted, and it usually erupts along a ring fracture of some sort, because there's so much material erupted, the magma chamber is evacuated, and the top block, the central block, tends to fall in on itself. And that's why you get caldera collapse. And then later on, this resurgent dome comes up, and the thought is on the resurgent dome is that the magma system is repressurizing itself and bowing up the thin central part. So what's usually exposed up here is the ash flow tufts, the rhyolite ash flow tufts that were formed in the climactic, the big eruption. These are the RO volcanics. These are a few later cinder cones. Now the resurgent dome is very curious because it stands very high. If you've seen the pictures of this, it's, I believe, approximately 800 meters higher than the caldera rim, which is, as far as I know, unheard of. And what's even stranger is that there's granitic rock, Cretaceous granitic rock, exposed in the resurgent dome. And this red here is supposedly the Miocene volcanic rocks, the Komondou Formation. So one of the most curious things is that I don't see the outflow sheets, the ash flow tufts, exposed inside the caldera. And with a resurgence of this magnitude, you would expect the older caldera fill of the ash flow tufts to be exposed. What you do find in here, besides the conglomerates, is the epiclastic conglomerates, is pyroclastic materials that Demont thinks are associated with these rhyolite domes. These are I don't know if they're rhyolite or dacite domes that have come up in the caldera ring fracture. Have you been in this caldera? No. One of the older papers, Schmidt, the fellow who actually did the dates, did a master's thesis on this area, and he dated the granite, not here, but there's another locality down in here someplace. Yeah, I'm not sure it's even labeled on this map. But there's one locality in this arroyo where the granite is exposed, and it's been dated there. It's Cretaceous. So we think, this is really Cretaceous.